Channel. So we started this classified structured data using Keras the last time, so we'll continue. Now I want to look at how we actually load the data. So we have been given the URL where the data set is sitting, and we can use the Keras ut.get file to extract that data. So I'm going to run that now. Now while that is running, let me get the import this and run this. As we can see here, you will see that the data set is actually being downloaded here. So that's what we specify the CSV file dataset pet finder and pet finder mini, and this is the dataset. If we click on this, we should see a preview on the left. Okay, so we have that data set here. Now we can inspect the data by checking the first 5 rows of that data, and you could see the categories, the different variables or features or columns: type, age, color, maturity, fee, description, photo, and all of that. You may want to do some descriptive analytics on that, and if you want to pick let's say the age, okay, or all the ones that actually have that are numeric, so you could use data frame.describe, and that's going to give no need of the 0, so that is going to give us the summary statistics of the numeric columns, like age, like the fee, photo, adoption speed, those who are numeric. So we can see here that this is the count of that. We have 11,000 plus 537. The mean, standard deviation, the median is 4. 25 percentile is 2. So 25% of the data is less than 2. 75% of the data is less than 12. So the maximum is 255. Similarly, we can see this one too. So what the author wants to achieve is actually to create a derived column as the target variable, and the approach is to actually create a bucket for that. So what's happening here is that we're transforming the problem into a binary classification problem, and the way that's going to work is any value in the adoption speed that is equals to 4, we make it to be 0, and any adoption speed that is not 4, we make it 1. So that's what this is doing here. So we have to predict whether a pet was adopted. So after modifying a column 0, we indicate that the pet was not adopted, and column 1 we indicate it was. So that's just the formulation. Okay, it was not adopted, column 0. Okay, so let's now look at this and how they actually use the numpy where. So I'm going to break it down quickly. So if we take this one, just that, what you'll be having is actually so if you take just this, so you're going to be having a series. So it means that you are picking out this column alone. From here, adoption speed, so you're going to be having a series. So you could see that, so that gives a series. These are the default indices, so these are the values there, 2032. So those are the values, as you can see here, 2032. Now what we now see here is that we can use the equals for comparison with a scalar. So this 4 is a scalar, and pandas will automatically broadcast it to compare each of these to the value here. So you could see that this is true, this is false. So by the time you compare this will be turned to either true or false. So watch, this will become true and this will become true. Every other thing will be false. So this is true, every other is false. Okay, so that is the result of this. So what the MP-ware does is that it takes a series, and if the result of the values of that Boolean series is true, it will replace it with 0. If it is false, it will replace it with 1. So if it is 0, if it is true, it is 0. So that's what's happening here. So if we now say mp dot where, and you wrap it around this, and you put the 0 and 1. So watch this. So what we'll be expecting is everywhere where we have true, we will have 0 and 0. All other places we're going to have 1 there. So you could see that. So this returns an array. So you see we have 1 every other place and we have 0 here. So this returns a numpy array. So now what we're now doing is we are now taking that return value and we're using it to make another column in our data set. So that's what this is doing. So it's creating another column just right after this, and it's giving it the value target. So the next is, since we're done with the adoption speed, you can just use a drop to drop it that and specify the columns as well as the descriptions which are not useful. So if we run the whole of this now, you will see that by the time we check the head again, so let's check the data frame and we check dot head, and we will see that we now have the target. You see we now have the target, so we turn that to a binary classification tags, and this is this adoption speed has been, description have been dropped. Okay, so this is pretty straightforward. Just use the numpy to split that. I think we're going to continue from here in the next one, so let's stop here. Thank you very much and see you in the next one.